All right, so remember a sequence is just a list of numbers in a particular order, but a series is a sum of numbers in a particular order. So when we're talking about sum, that means we're now adding all the numbers. So I gave the example 2, 4, 6, 8 earlier, where a series would be 2 plus 4 plus 6 plus 8 and would end up actually equaling something. The main difference between an arithmetic sequence and an arithmetic series is that a sequence is a list, and a series is a sum. Just like we had before for the equation or a formula for the arithmetic sequence, we have a formula for the arithmetic series, where n is the number of terms, s sub n is the sum of those terms, and a1 is your first term, a sub n is your last or nth term. And so let's define those variables here. This is your first number, last number. N is the number of terms. D is your common difference. And then the S sub n is the sum, or the final sum when you add all the numbers together. So find the sum of the first 100 positive integers. So let's think about what these pieces of the equation are. So what is my first positive integer? Well, 1. What's my 100th positive integer? 100. And so we think about, well, let me just say, the 100th term is 100. The 100th term is 100. So that means n is 100. So I've just found n to be 100 and the value of n to be 100. The common difference, what do we go up by each time? My common difference is 1. And so I think I have everything. I have a 1, I have a n, I have n, and I have the common difference d. Now, d isn't actually used in the equation, but you'll see why it's useful later. So I've got the sum of the first 100 positive integers is n over 2, so 100 over 2, times the first term plus the last term. And so we end up getting, for this, 5,050. Now, what could we do without using this equation? We could list 1 through 100 and just add all those numbers together. It'll take a little bit of time, but it's possible. This is just a shortcut to do it. So in example 2, they're asking us to find the sum of the arithmetic series. Sorry, 2b. Find the sum of the arithmetic series if we have a1 is 7, an is 79, and n is 8. So they're giving you exactly what you need. You just have to be able to fill it into the equation. So we're looking for the sum of the first 8 terms because they said n is 8. And it's n over 2, so 8 over 2. And then we have times a1, which is 7, plus a sub n, which is 79. If we do that out, we get 344 for the sum. Part C, find the sum of the first 28 terms. So they're giving me n. If the series, the first term is 2, so a1 is 2. The last term is 83, so we've got a sub 28 is 83. Or a sub n, if you want to think of it like that. So we've got the sum of the first 28 terms would be 28 over 2, and then a1 plus a sub 28. And here we're going to get 1,190. For D, find the sum of the first 15 terms, so that's n. Sum, we're looking for s sub 15. And then they gave us the sequence. So they're giving us a 1, and they're giving us a sub 15, or you could think of that as a sub n. So they give us what we need. S sub 15 is n divided by 2 times a 1 plus a sub n, or a sub 15. So we subtract that, multiply by 15 over 2, and we get 487.5. Now, that answer doesn't actually make sense for the sequence that we see here. It's because it's just a bad question. The series that I wrote here doesn't actually work or make sense, but we did it right. So as long as we know the first term and the last term and the number of terms, we did the process right. It's just that the question wasn't very good. E, find the sum of the first 30 terms. So n is 30. The first term is 2. And the common difference is 6. So here they're giving me something different. They're not giving me a sub n. So in order to do the equation, I'm going to need to find a sub n using the common difference. So I'll show you what I mean. We're looking for the sum of the first 30 terms, and we've got n, and we've got the first term, but we don't have a sub 30. We don't have that 30th term yet. So we have to find it. So then we go back to our old formula to find the 30th term, the nth term. And so if we go back to our old equation, that was a sub 1, which is 2, plus n minus 1, so 30 minus 1, times the common difference, 6. So this is that formula from the beginning of the notes. And so here we get 29 times 6, which ends up giving us 176 for that number. So now we can finish the equation. Type that in, we get 2,670 for the sum of the first 30 terms. F, find the sum of the first 42 terms if the first term is negative 12. The common difference is 2. So this is just like that last one. If you want to pause it and try it on your own first. And so I've gone through and I found that when you fill in your N, your A1, and your D, well, we don't fill in the D yet. When you fill in your N and your A sub 1, you're missing your 42nd term. So just like on the last one, we found the 42nd term. And then you get 70, and then you're able to fill it in for the A sub 42. And then here you end up getting 1,218. Now, the next two are very similar to that, only they're written in sigma notation or summation notation, whichever way you want to say it. So for G, so let's kind of think about what we need here. We've got S sub n equals n over 2, A sub 1 plus A sub n. So my n is the number of terms, and we can see by looking at the top of the sigma what our n value is going to be. So we know that n is 48. So when we fill in our equation, all we need is A1 and A sub 48. To find A1 and A48, we just need to look at the rule given to us and plug in those numbers. So to find A1, we are just plugging in 1 into the equation. So that'd be 2 times 1 plus 1, which is 4. A sub 48, we plug 48 into the equation. And we're getting 98 for that. So we're using the sigma notation to find all of our missing information, and then we just fill it in. So we've got sum of the 48 terms is 48 over 2, and then A1 plus A sub 48, and you end up getting 2,448. If you want to try the next one on your own before I do it, go ahead and pause the video now. But over here, so we have S sub n over 2 times A sub 1 plus A sub n. My n is 20, so we fill that in. So that means I need to find my A sub 1 and my A sub 20. A sub 1, we plug in 1 into the rule. And A sub 20, we plug in 20 to the rule. And we get negative 2, and we get 74. So then we have everything we need. And so the sum of the first 20 terms is 720.